Hello student, now we will start the first chapter from the CBSC 11th standard so that it will help to all the Maharashtra board student for the preparation of CET exam as well as JEE examination. Now let us start the first exercise 1.1. I will explain first of all basic and then we will take the exercise 1.1. Now let us start. Chapter number 1, sets. Introduction. The concept of sets serves as a fundamental part of the present day mathematics. Today, this concept is being used in almost every branch of mathematics. Sets are used to define the concepts of relations and functions. The study of geometry, sequences, probability, etc. requires the knowledge of sets. The theory of sets was developed by German mathematician Georg Cantor. He first encountered the sets while working on problems on trigonometric series. In this chapter, we discuss some basic definitions and operations involving the sets. Next, sets and their representation. In everyday life, we often speak of collections of objects of a particular kind, such as a pack of cards, crowd of people, a cricket team, etc. In mathematics also, we come across collections, for example, of natural numbers, points, prime numbers, etc. More especially, we examine the following collections. Now again, this will be again repetition. Sets and their representation. In everyday life, the same thing is repeated here. In everyday life, we often speak of the collections of objects of particular kind, such as a pack of cards, a crowd of people, a cricket team, etc. In mathematics, also, we come across collections. For example, this is also repeated. For example, the natural numbers, points, prime numbers, etc. More especially, we examine the following collections: are natural numbers less than 10, that is 1, 3, 5, 7, 9, odd natural numbers less than 10. That is 1, 3, 5, 7, 9. Next one. The rivers of India. The vowels in English alphabet, namely A, E, I, O, U. Various kind of triangles, prime factors of 210, namely 2, 3, 5, and 7. The solution of the equation x square minus 5x plus 6 equals to 0, namely 2 and 3. We note each of the above example is a well-defined collection of objects in the sense that we can definitely decide whether a given particular object belongs to a given collection or not. For example, we say that the river Nile does not belong to the collection of rivers of India. Next. On the other hand, the river Ganga does belongs to this collection. We give below a few more examples of sets used particularly in mathematics, namely N, the set of natural numbers, Z, the set of all integers, Q, the set of all rational numbers, R, the set of real numbers. Z plus, that is a set of positive integers, that is a plus sign denotes only the positive integers. Q plus, again the same, the set of positive rational numbers, and R plus, the set of positive real numbers. The symbols for the special sets given above will be referred to throughout this textbook, that is in this lecture also. Again, the collection of 5 most renowned mathematicians of the world is not well defined, because the criteria for determining a mathematician as most renowned may vary from person to person. Some will say that he is doing in pure mathematics, he is doing applied mathematics. It may be different, therefore it is not the collection of sets that is the 5 most renowned mathematicians of the world. Thus, it is not the well-defined collection. We shall say that a set is a well-defined collection of objects The following points may be noted. What is the first? Objects, elements, and members of sets are synonymous terms. Sets are usually denoted by capital letters A, B, C, D or X, Y, Z, etc. The elements of a set are represented by small letters, small a, b, c, x, y, z, etc. If A is an element of a set, capital A, we say that A belongs to capital A. The Greek symbol, that is epsilon, is used, this is symbol, is used to denote the phrase belongs to. Thus we write A belongs to capital A, small a belongs to capital A. If B does not an element of a set A, we write B does not belongs to A and read as B does not belongs to A. Thus, in the set V of vowels in English alphabet, A belongs to V, but B does not belongs to B. B is not vowel. In the set P of the prime factors of 30, 3 belongs to P, but 15 does not belongs to P because 15 is not prime. There are two methods of representing a set. First, roster or tabular form. Second, set builder form. In roster form, all the elements of a set are listed. We take the list of all the elements. The elements are being separated by commas and are enclosed within the braces like this in curly bracket. For example, the set of all even positive integers less than 7 is described in roster form. What type of the numbers? Even, positive, less than 7. Therefore, 2, 4 and 6 in the roster form. That is, we take the list of elements. Some more examples of representing a set in roster form are given below. The set of all natural numbers which divides 42. And what are that numbers? 1 that divides 42, 2 divides 42, 3 divides 42, and in this way these are the natural numbers which divides 42. 1, 2, 3, 6, 7, 14, 21 and 42. Next is, note that in roster form, the order in which the elements are listed is immaterial. You can write 42 first of all, then one last also, therefore the order is immaterial. Thus, the above set can also be represented as 1, 3, 7, 21, 2, 6, 14 and 42. B. The set of all vowels in English alphabet is A, E, I, O, U. C. The set of odd natural numbers is represented by, that is 1, 3, 5 and dash dash. Okay. that is a dot dot. The dot tells us that the list of odd numbers continue indefinitely. Note, it may be noted that while writing the set in roster form, an element is not generally repeated. That is, all the elements are taken as distinct. For example, the set of letters forming the word school is SCHOL or HOLCS. Here O is repeated, therefore it is taken as a single time. Here the order of listing element has no relevance. Second, in set builder form, all the elements of a set possesses a single common property which is not possessed by any element outside the set. For example, in set AEIOU, all the elements possesses a common property, namely, each of them is OL in English alphabet and no other letter possesses this property. Therefore, B is equals to X is such that X is a vowels in English alphabet, denoting this set by V, and we write it. What is that property? That V is equals to, in curly bracket, X is such that X is vowel in English alphabet. It may be observed that we describe the element of the set by using a symbol X. You can take any other symbol like the letters Y, Z, etc. could be used, which is followed by a colon like this. After the sign of colon, we write the characteristic property possessed by elements of the set and then enclose the whole description within the braces. The above description of the set V is read as the set of all X such that X is vowel of the English alphabet. In this description, the braces stands for the set of all. The column stand for such that. For example, the set capital A is equals to set of all X is such that X is natural number and X lies between 3 and 10 is read as the set of all X such that X is natural number and X lies between 3 and 10. It's very simple. Hence, the numbers 4, 5, 6, 7, 8 and 9 are the elements of set A. If we denote the sets described in A, B and C above in a roster form by capital A, capital B, capital C respectively, then ABC can also be represented in set builder form as follows. Capital A is equals to X is such that X is natural number which divides 42. B, Y is such that set of Y is such that Y is vowels in English alphabet. C is equals to Z is set of such that Z is odd natural number. Example 1. Write the solution set of the equation x square plus x minus 2 is equals to 0 in roster form. That is, we list it. Now the solution. The given equation can be written as x minus 1 into in second bracket x plus 2 is equals to 0. Therefore, the factors are x minus 1 and second factor is x plus 2. Therefore, x minus 1 is equals to 0 and hence x is equals to 1. Second, x plus 2 is equals to 0. Therefore, x is equals to minus 2. Therefore, the solution set of given equation can be written in roster form as 1 minus 2. Next example. Example 2. Write the set x is such that x is positive integer and x square is less than 40 in a roster form. Set of positive integers. Therefore, the solution. The required numbers, that is 1 square is less than 40, 2 square is less than 40, 3 square is less than 40, 4 square is less than 40, 5 square is less than 40, 6 square is less than 40. But the 7 we cannot take. So 49. Therefore, the required numbers are 1, 2, 3, 4, 5, 6. So that the set in the roster form is 1, 2, 3, 4, 5, 6. Now next is example 3. Write the set A 1, 4, 9, 16, 25 dash dash in set builder form. We see this, these numbers are the square. Now the solution. We may write the set capital A as capital A is equals to x is such that x is the square of a natural number, and alternatively we write x is such that x is equals to n square, where n belongs to set of natural numbers. This can be also written as that x is such that x is a square of natural number, or you can write this also. Next example. Write the set 1 upon 2, 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6, 6 upon 7 in set builder form. We see the numerator and the denominator. Denominator is more than numerator by 1 and numerator starts with 1. Now the solution. We see that each member in the given set has numerator 1 less than the denominator. Also, the numerator begin from 1 and do not exceed 6. Maximum numerator is 6. Hence, in the set builder form, the given set is x is such that x is equals to n upon n plus 1. If we take n is equals to 1, then 1 upon 1 plus 1, that is 1 upon 2. If we take the x is equals to n is equals to 2, then 2 upon 2 plus 1, that is a 2 by 3. And what about here n? N lies between 1 and 6, equal to 1 also and equal to 6 also. Now the example 5. Match each of the set on the left described in roster form with the same set on the right described in the set builder form. First, principal in first set. Now you can see this. For the first group is a principal, next is a 0, third is 1, 2, 3, 6, 9, 18, 3 minus 3. Okay. Now see this here. We have the two groups, principal 0, 1, 2, 3, 6, 9, 18, 3 minus 3. On another group, x is such that x is positive integer and is divisor of 18. Next, x is such that x is integer and x square minus 9 is equals to 0. X is such that x is an integer, x plus 1 is equals to 1. X is such that x is a debtor of the word principal. Now see this here, that is the principal, that is the first and D. 0. What about here? That x is in integer and x plus 1 is equals to 0. Which is the integer? That is a 0 plus 1 is equals to 1. Therefore, second match with C. And what about here? 1, 2, 3, 6, 9, 18. That is A. X is such that x is positive integer and is a divisor of 18. All these are the divisor of 18. And what about 3 and minus 3? Here's a B. X is such that x is an integer and x square minus 9 is equals to 0. If we take x is equals to 3, 9 minus 9 is 0. X is equals to minus 3. Again 9 minus 9 is 0. And in this way, now see this answer. Solution in D. There are the 9 letters in the word principal. And 2 letters P and I are repeated. So first matches D. Similarly, second matches C, as x plus 1 is equals to 0. This implies that x is equals to 0. If we solve it, you will get x is equals to 0. Also, 1, 2, 3, 6, 9, 18 are all divisors of 18. And so, third matches A. Finally, x square minus 9 is equals to 0. Implies x is equals to 3 minus 3. And so, fourth matches B. Now the next is a correct answer is here. Okay, this is answer written in class view. Exercise 1.1. Now take the exercise. First, Which of the following are sets? Justify your answer. First, the collection of all the months of a year beginning with the letter J. Solution. The collection of all months of a year beginning with the letter J is a well-defined collection of objects because one can definitely identify a month that belongs to this collection. They start with the J, beginning with J. Hence, this collection is a set. Simple question. Second, the collection of 10 most talented writers of India. Again, this is not the set. The collection of 10 most talented writers of India is not a well-defined collection because the criteria for determining a writer's talent vary from person to person, and hence this collection is not a set. Simple. Next. A team of 11 best cricket batsmen of the world. Again, a team of 11 best cricket batsmen of the world is not a well-defined collection because the criteria for determining a batsman's talent may vary from person to person. Hence, this collection is not a set. Next, the collection of all boys in your class. Yes. Solution. The collection of all boys in your class is a well-defined collection because you can definitely identify a boy who belongs to this class, this collection. Hence, this collection is a set. The collection of all natural numbers less than 100. Yes. The collection of all natural numbers less than 100 is a well-defined collection because one can definitely identify a number that belongs to this collection. Hence, this collection is a set. Next is a collection of novels written by Munshi Prem Chand. Yes, a collection of novels written by the writer Munshi Prem Chand is a well-defined collection because one can definitely identify a book that belongs to this collection. Hence, this collection is a set. The collection of all even integers, again this is a set. The collection of all even integers is well defined collection because one can definitely identify an even integer that belongs to this collection. Hence, this collection is a set. Next, the collection of questions in this chapter. Yes, this is set. The collection of questions in this chapter is a well-defined collection because one can definitely identify a question that belongs to this chapter. Hence, this collection is a set. Next, a collection of most dangerous animal of the world. This is not the set. Okay. Solution. The collection of most dangerous animal of this world is not well defined collection because the criteria for determining the dangerousness of an animal can vary from person to person. Hence, this collection is not set. Next question. Let A is equals to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs to or does not belongs to in the spaces, in blank spaces. First, what is here? 5. 5 belongs to A. It's clear that A contains the 5. Next, 8 does not belongs to A. 0 does not belongs to A. Next question. That is same question. Again, 4 belongs to A. 2 belongs to A. 10 does not belongs to A. Next question. Write the following sets in roster form. First, A is equals to, in curly bracket, x is such that x is an integer and x lies between -3 and 7 and x is equals to 3 -3 also. Okay. Now here, the given set can be written in a roster form as -3, -2, 1, 0, 1, 2, 3, 4, 5, 6. Okay. Next is the question number is immaterial. You can write this question from the textbook. B is equals to x is such that x is natural number less than 6. Okay. The given set can be written in the roster form as B is equals to 1, 2, 3, 4, 5. Third, C is equals to x is such that x is 2-digit natural number such that the sum of its digit is 8. Okay, it's a very nice question. 2-digit is natural number, sum of its digit is 8. Now this set can be written as in the roster form. C is equals to 17, 1 plus 7, that is 8, 2, 6. Again 2 plus 6 is 8. And in this way we get the numbers 17, 26, 35, 44, and then 53, 62. Now see this here 26 and 62. 17, 71, and again here 80. Next, D is equals to x is such that x is a prime number which is a divisor of 60. Now this set can be written in the roster form. We require the prime numbers only. That is the 2, 3, 5. These are only the prime numbers which are the divisors of 60. Though we have the 6, 4, 10, 15, 30. But all the numbers are not prime. But the prime numbers are only the 2 divides 60, 3 divides and 5 divides. And these are the prime numbers. E, the set of all letters in the word trigonometry. Now this set can be written in the roster form as E is equals to TRIGONMEY. Sixth one, the set of all letters in the word better. Again, this set can be written in the roster form as F is equals to, in curly bracket, BETR. Next question. You don't see this number, you can see this number from the textbook. I had written 1-1 to all questions. Write the following sets in set builder form. Now see this here. By mistake here is the rounded bracket, but must be the curly bracket. That is a 3, 6, 9, 12. Now here 3, 6, 9, 12. What type of these numbers? These are the multiples of the 3. Therefore x is such that x is equals to 3n, where n belongs to set of natural number. But what type of the n must be? N must lies between 1 and 4 and equal to 1 and equal to 4 also. Okay. If you take n is equals to 1, then you will get 3. N is equals to 2, then you will get 6, and in this way. Next question. 2, 4, 8, 16, 32. Now 2, 4, 8, 16, 32. It can be seen that is a 2 is equals to 2 raised to 1. 4 is equals to 2 raised to 2. 8 is equals to 2 raised to 3. And 16 is equals to 2 raised to 4. And 32 is equals to 2 raised to 5. Therefore, the 2, 4, 8, 16, 32 is equals to x is such that x is equals to 2 raised to n. And n belongs to set of natural number. And the value of x, n lies between 1 and 5, equal to 1 and equal to 5 also. Next is, now the next question, 5, 25, 125, 625. 5, 25, 125, 625. It can be seen that 5 is equals to 5 raised to 1. 25 means what? 5 raised to 2. 125, 5 raised to 3. And 625, that is 5 raised to 4. And therefore this can be written as x is such that x is equals to 5 raised to n. N belongs to set of natural number and n lies between 1 and 4 and equal to 1 also and equal to 4 also. 2, 4, 6, 8. Dash. These are the even numbers. It is a set of all even natural numbers. 2, 4, 6, 8. X is such that X is an even natural number. Next question. List all the elements of the following sets. First, A is equals to X is such that X is an odd natural number. Therefore, A is equals to in curly bracket X is such that X is an odd natural number. 1, 3, 5, 7, 9 and dash dash. Next is second. B, X is such that X is an integer minus X is an integer lies between minus 1 upon 2 and 9 by 2. X is such that X is an integer lies between minus 1 upon 2 and 9 upon 2. It can be seen that minus 1 upon 2 is minus 0.5 and 9 by 2 is 4.5. We require the integers and not fraction, and therefore the numbers are integer, means 0, 1, 2, 3, 4. These are the integers lies between minus 0.5 and 4.5. That is minus 1 upon 2 and 9 by 2. Next is C is equals to in curly bracket X is such that X is an integer and X square is less than or equal to 4. C is equals to in curly bracket X is such that X is an integer, X square is less than or equal to 4. It can be seen that is minus 1 square is 1, which is less than or equal to 4. Minus 2 square is equals to 4. It is less than or equal to 4. Minus 3 square is 9, which is greater than 4. Therefore, we cannot take minus 3. Then what are the numbers? The numbers are minus 2. Its a square is a 4. Minus 1. We can take 0, 1 and 2. These are the integers whose square is less than or equal to 4. Next question. D is equals to in curly bracket X is such that X is a letter in the word loyal. Again, in curly bracket, by mistake, here is a rounded bracket. X is a letter in the word loyal, that's equals to L-O-Y-A. Next, E is equals to in curly bracket X is such that X is a month of a year not having 31 days. And X is a month of year not having 31 days is empty set. Okay. Next is F is equals to X is such that X is constant. X is a consonant in English alphabet which precedes K. That is so the solution is F is equals to X is a consonant in English alphabet which precedes K, that is before K. These are the consonant. Okay. But here we cannot take here, that is F is equals to, because we require the consonant Therefore here we actually write F is equals to, and this is not. We have taken all these letters. Here is F, that is a B, C, D, F, G, H, I. These are all the letters before K. Okay. And the answer is this. Next, match each of this set on the left in the roster form with the same set on the right, described in set builder form. First is 1, 2, 3, 6. See this here. Again 2, 3. Next is Matheics. And the fourth one is 1, 3, 5, 7, 9. What about here? Another group, that is x. X is such that x is a prime number and a divisor of 6. X is such that x is odd natural number less than 10. X is such that x is a natural number and divisor of 6. Okay, X is the letter of the word, which is the word mathematics. Okay, so clear that 1, 2, 3, 6. Now, what is here? X is a natural number and divisors of 6. What is this? 1, 2, 3, 6. These are the natural numbers and all these are the divisors of 6. Therefore, the first matches to C. Next is 2, 3. What about here? 2 and 3. These are the prime numbers and these are the divisors of 6. Okay. Therefore, second matches to A. Matheics. Okay. X is a letter of the word mathematics. Therefore, third matches to D. And what about here? 1, 3, 5, 7, 9. X is odd natural number less than 10. Therefore, fourth matches to B. Okay. All this is the description. You can see this here. And these are the correct pairs. 1, 2, 3, 6. X is the natural numbers and these are the divisors of 6. 2, 3. X is a prime number and a divisor of 6. Next is Matheics. That is a word of the letter mathematics. And the next is a 1, 3, 5, 7, 9. That is a X is odd natural number. These are the less than 10. And in this way, I have completed the first exercise. I will see in the next video. Till then, goodbye.